Okay, enough already. I know everybody's saying, aren't you supposed to talk about astronomy? This is Starry, Starry Night. And I thought, well, okay, fair enough. I'm still sticking with the atmosphere a little bit because there's still some neat things that can happen with the atmosphere, like the aurora. And usually you can tell, can you see it here in this picture? From my angle, I'm not sure I can appreciate it, but the Milky Way is there, and you can tell that this is the aurora borealis. All sorts of, thanks, Rob. Lots of interesting colors. Usually green, sometimes red, and amazing things to see. And there's no real good predicting this. You just have to kind of be lucky and look at the night sky a lot. Most times it'd be green. In fact, most of the colors all come from oxygen. O2 will be green, O3 will be red, that's ozone. And so you'll sometimes see it, this picture. Here you can see, I think, the Milky Way, if I remember correctly, in this picture. From this angle, again, I'm still having a hard time seeing it, but so this tells you it's the aurora borealis. Now, lots of times people describe it, it looks like ribbons. And if you watch it, you'll notice this sort of undulation of it with time. It's slow moving, but it's definitely there. And some people will even say they can hear a crackling sound in the sky. So it's really quite neat to see. It's amazing to watch. Now, if you were on the space station, this is what an aurora would look like up there from that view, because it is within that upper layer of the atmosphere, very high up. And if you were in a satellite, you'd be able to see it like this. Now, obviously, this is at the South Pole, because there's Antarctica. It's called the aurora borealis when it's at the North Pole. Anybody know what it's called when it's at the South Pole? I heard it. Aurora australis, that's right. And you can see it's this nice big ring that surrounds the pole. So this is my last final science-y slide, just to sort of show you. See, the thing about the sun is it's not just giving us light and heat, it's hurling out all sorts of solar particles. It's called the solar wind, ionized little particles. And to be honest, they would destroy the planet if we didn't have something to protect them. And thank goodness we have a magnetic pole in the way the planet is, so that it tends to be all deflected towards both the south and the north poles. And as a result, it doesn't damage the rest of where we all tend to live. And every once in a while, funny things happen, like satellites get destroyed because of these things. But that's why they tend to occur in those areas. Now, sometimes they're very broad sweeping, and they've seen them as far south as Texas and Mexico. But now, the next thing that happens in the atmosphere is the meteors. And I think probably everybody's seen a shooting star at some point in their life. The thing about a meteor is it tends to be very brief, lasts only a matter of seconds, gets very bright, and then it's gone again. And you don't always know when they're going to occur, although sometimes you do. If it ever gets to the ground, it's called a meteorite. So a meteor is what you see in the sky, a meteorite is what lands on the ground. And this is a pretty sizable one, a few centimeters large. They're usually just iron ore type compounds that exist from the beginnings of the solar system. Most of them, though, are just smaller than a peanut and often just very small dust particles, and they just incinerate in the atmosphere and never even make it to Earth. So if one ever does land on the ground, it's quite a precious find. But where do they come from? Well, it's all this kind of dust particles. Now, this is a view from above our solar system. So there's our sun. This is the orbit of Earth in 3-month intervals: May, August, November, and February. And I'm showing you this because Comet Swift-Tuttle happens to orbit at about 130 years. Just hit in 1992, it went by. And it happens to cross the plane. And so if you have a big, dirty snowball, which is really all a comet is, and it goes through our solar systems, or through our Earth's orbit pathway, it'll leave a bunch of little residue particles, lots of little dirty bits in the sky, that when Earth moves through it, will hit those. And that's where meteor showers will occur. So the Perseids, which are probably the best known meteor shower, partly because it happens at a nice time of the year, August 11th, is where you'll see a whole bunch of meteors in one night. By the way, I'm not joking about this. Whoever at your table has a birthday closest to August 11th gets the centerpiece. There you go. So every August 11th, there will be a meteor shower called the Perseids. And let's just explain that a bit. What that means is if you look at the night sky, and everybody's so excited about a centerpiece. Y'all have to figure it out. Perseus is a constellation in the night sky, and what happens when we see these meteor showers is that all of them will tend to radiate out from a very specific point, and it's called the radiant. And in this case, it's in Perseus, and thus the Perseids. But there's the Orionids, there's the Leonids, depends on what constellation they come from. And the way to think about that is, the reason this occurs is because that is the exact direction Earth is moving in at the point of the meteor shower. That's where we're headed. Think of it when you're driving through snowstorm, and you see all these snow particles hitting your windshield, and they all seem to be coming from one spot. That's essentially what happens when Earth is barreling through the residue of this comet. Interestingly, Swift-Tuttle someday will probably hit the Earth or the Moon. Thankfully, it doesn't seem it'll be in the next 1,000 years, but because the two paths cross in the next number of millions of years, it probably will happen. So it's a bit of a scary thought. Now, another thing to see in the atmosphere are satellites, and I'll just show you the International Space Station, which is probably the biggest and most exciting one. The difference about a meteor versus a satellite: a meteor will just streak across in seconds, get very bright, and then disappear. A satellite will take minutes to cross, and it will be a very uniform speed and a very uniform intensity of brightness. So as you can see, this took a few minutes. When the shutter was left open, you can see all the little streaks of the stars because the sky had moved in that much time. The wind had blown the trees back and forth. But these are predictable, and if you actually do a Google search for the International Space Station sightings, it'll be able to predict when it will occur, and it'll tell you, go out at 10:43, look in the northwest, it'll take 3.5 minutes to cross, and will end in the southeast, and it will show you all of those sorts of things. And it's quite neat. I looked it up for this talk, but actually we're just not at the right sighting. There's no ISS sightings for the next 2 weeks, but it's always going to come around eventually again where you can see it, so it's something to look up. But let's move on a little bit. Now we're comfortable with home. Let's move on. Our closest neighbor is going to be the moon. And the moon, Luna, Selena, depends on what you know her by. This is a picture from the Galileo spacecraft that left in 1989 and ended up heading towards Jupiter. And they said, let's take a look at Earth and the moon together. So this is actually a shot. It's not a composite. It's a real picture of the two together, the first one that ever existed like that. They did have to adjust for the intensity of lighting because the moon isn't as bright as the Earth for obvious reasons, just because this is so much bigger. But I think it's kind of a neat picture to see. Now, when the moon is new and you see the bright little crescent, usually you can see the whole rest of the moon though. And in fact, we'll often call this the old moon and the new moon's arms. What is lighting up the rest of the moon there? Anybody know? It's obviously not the sun, right? Because the sun's only lighting up that crescent. Any ideas?
The Earth.
The Earth. When the moon is just barely new, then the Earth is almost fully lit up. So that's Earth shine on the moon. And if you were standing on the moon there, you would see a very bright, brilliant Earth in the night sky for you. So that's what lights that up. And of course, as the moon goes through its phases, you start to lose a little bit of that. So it's very good when it's a very new moon.